hi class.
Hi.
Today we're going to do the study guide answer key, so follow along with me. Which of the following relations represent functions? And remember, one input to one output. Well, any equation like y equals mx plus b, so a is going to be a function for sure. One input, one output, right here. A negative 2 gives me a 2, and a negative 2 gives me a 3. That's one input to two outputs. That's not a function. Functions have one input, one output. We test the linear, the vertical line test, meaning if I draw a straight line, I only hit it once at all times. It's a function. One input, one output, one input. This has one input, two outputs. That's not a function. And I'm looking here. If I plug in a negative 2, I get out of 8. I plug in a 1, I get out of 8. Plug in a 4, get out of 8. Well, that's okay because it's still one input, one output. That's a function. Your answers are A, C, and E. All right. Use the graphs below to complete all parts. Which graphs have a range of all real numbers? Now, all real numbers just means numbers. Anything from decimals to fractions to negatives to positives. All real numbers, so we're talking range. Remember, range is y, domain is the x. So the range of all real numbers, the only answer is possibly a C, because C goes to the positives and to the infinities. I mean the negatives. D only goes to the positives. B touches a little bit of positives, but only goes to the negatives. And A is just a weird circle. Which graphs have a domain of all numbers? That means all the negative numbers and all the positive numbers on the x-axis. Well, B does, because it goes on forever this way and that way. C does, because it goes forever that way and that way. And D does, because it goes forever this way and that way. Which graphs have a range of only positive numbers? Well, B has a range of negatives, C touches the negatives, A touches the negatives, but D does not. And which ones are functions? B, C, and D. Because if I do a line through A, I hit it once and twice. That's not a function. How are we doing, class?
Good. Pretty epic. Yeah, I literally got that whole thing wrong.
All right, here we go. Use the graph to determine the following, each statement true or false. This graph represents a function. That's true. The domain is only positive numbers. That's false. Remember, the domain is x, and it eventually hits the negative numbers. The range is all numbers greater than or equal to 1. Right there, there's the 1. It's all things of greater than. That's true. The function is nonlinear. That's true. There are two different inputs that have an output of 4. Well, here's 4. If I draw a line across the 4, it hits it once here and once there. So if I plugged in this number, I'd get out of 4. And if I plugged in this number, I'd get out of 4. So there are two different inputs. True. Nonlinear. It's nonlinear because it turns. There's a turn in it. Yep. All right, number 4. Which of the following equations represent linear functions? Well, basically, I'm looking for anything without exponents. So, like, if there's an exponent, the line curves. So A is not one. D is. B is. E is not one. That's a line that does that. And you can also plug these on Desmos and check them too if you really want. So A, so no, C, no, so it's D, B, C, and F. Which of the following represents a linear function? Now remember, linear means straight line or constant, right? So constant. So A curves, that's not linear. C's pretty obvious. It's a straight line, that's linear, which means E would not be. So now we look here. It's going up 4, up 4, up 4. Ooh, nope. Then it goes back down 4, down 4. It changed. That's not consistent, so B's not a linear function. up 4, up 4, up 4, up 2, up 2, up 2. That's constant. D is a linear function. Up 1, up 2, up 4. That's not constant. So the answers are only C and D. Ooh, number 6. The table shows the earnings in dollars. You're working for X hours. Determine the missing Y value in the table that makes the table represent a linear function. So the question is how much money are you making each hour? Well, you made $108.70. So you go on the calculator. $108.70 minus $99.30. You get a whopping $9.40 per hour. All right. So it's $9.40 per hour. So that means this has to be $99.40 cheaper than that. So 99.3 minus 9.4 gives me 89.9. So $89.90. $89.90. What is your hourly pay rate? $9.40 per hour. You see it right here in between each dollar amount per hour. Woo! Ooh, function notation, right? So here's the function f, here's the function g. Find f of 3. That means use the f function and plug in a 3. Negative 5 times 3 is negative 15. What's negative 15 plus 2? Negative 13. Right? So now, f of x equals negative 23. So it's working backwards. We don't know what to plug in, but we know what it equals. So we know that negative 5x plus 2, which is f of x, has to equal negative 23. So then I would add 23, add 2 to both sides. You get negative 5x equals negative 21, and then it would divide by negative 5. X equals 21/5. 2 negatives make a positive. Can't divide it by 5, so we're just going to leave it as a fraction. All right, what do we do if f of x equals 12? Well, same thing. Plug in 12, so negative 5x plus 2 equals 12. Subtract 2 from both sides, we get negative 5x equals 10. 10 divided by negative 5 is negative 2. And then g of 9, go to g, plug in a 9. 9 squared is 81. So far, so good. All right, now that I had the class leave, we can kind of do it a little bit so it's not so much background noise now. Okay, the temperature, oh, there's the bell. The temperature in degrees Fahrenheit of a turkey cooked in the oven can be represented with the function T of x, where the input x is the minutes. So x is the minutes the turkey's been in the oven, right? So T of x will tell us the temperature of the turkey after it's been cooking in the oven. So, okay, so then what does T of 150 represent? Well, remember x, so it was T of x, but now it's 150. And x is the minutes of the turkey. So that tells me the turkey's been in for 150 minutes. So the temperature initially placed right there. The temperature of the turkey after 150 minutes of being in the oven. You would think it would be the third one, which is 150 degrees, but that's wrong. It's the temperature after 150. So now if I'm given T of 0 equals 68, explain the meaning of this statement. Well, that means at time 0. So before the turkey goes in, so before turkey goes in, because we're at 0 minutes, it is 68 degrees, or probably room temperature is what that's representing right there. Hey, we're on the last page now, right? Okay, so use the function f of x to complete all parts. So here's the function right here. So this is f of x, right? That's what the function is. What is f of 2? So f of 2, where x equals 2. So x equals 2 right here. And if I go up, it hits right there at 1, 2, 3. So this is 3. So f of 2 equals 3. Because that means if I plug in a 2, I get out a 3. Find all the values of x such that f of x equals 3. So where will the function equal 3? So here's 3 right there, and it equals it right here and right there. That means if I plug in a 2, I get out a 3, and if I plug in a negative 2, I get out a 3. So the answer is negative 2 and 2. Place one of the following symbols, greater than, less than, equal to, in the blank space to make the true statements true. So what is f of negative 3? F of negative 3 is right here, which is a little bit above 4. So there's f of negative 3. And f of 1 is right here, f of 1, which is a little bit above 2. So therefore, this right here, f of negative 3, is going to be like, 4 point something. And this is going to be, 2 point something. So therefore, this is going to be greater than that because it's higher up on the graph. Cool. Which graph matches the equation? Y equals negative 1/3 x plus 5. So that tells me it's going through the y-intercept. Remember, this is the y-intercept at 5 with a slope of negative 1/3. So that tells me it's going to go down 1/3, down 1/3, down 1/3. So you're going to get a line looking something like this. And the only possible one looking with a negative line going through 5 would be right here, where it crosses probably at 5, and then it goes down 1/3, down 1/3. So it would be this one right there. Use the function 2x minus 5y equals 10 to complete all the parts. Rewrite the equation in slope-intercept form. Well, remember, any equation, 2x minus 5y equals 10, can be wrote in slope-intercept form if you solve it for y. So we need it to be y equals. So I'm going to subtract 2x from both sides. I get negative 5y equals negative 2x plus 10. I then divide everything by negative 5. And I get y equals 2/5 x, because two negatives make a positive, minus 2. So y equals 2/5 x minus 2. Find the x, y-intercepts, and the slope. Okay, well, we learned that x and y's are these zeros, right? So if like 2x minus 5y equals 10, if I made x equal 0, what does y equal? Well, if x is 0, that's gone. Negative 5y equals 10. If I divide both sides by negative 5, y equals negative 2. Okay, y equals negative. So the y-intercept is at 0, negative 2. Now, if I plugged in a 0 for the y, what would x equal? So if I plugged in a 0 for the y, 2x equals 10 divided by 2, x equals 5. The x-intercept is at 5, 0. And the slope, well, we already solved the equation for slope-intercept form. The slope is right here at 2/5. So therefore, if we were to graph this equation, it would cross the x-axis at 1, 2, 3, 4, 5, cross the y-axis at negative 2. There's your line, and you can see your slope of up 2/5 right there. Okay, there's the answer key to the study guide. So this is the answer key for you. Good luck.